Hey guys, welcome back to another video. So I used the lightweight Java game library tutorial to add in prototype sounds. So let's just get into it, and I'll full screen this for you guys so you can see very easily all that good stuff. I'm not sure how loud this is going to be, so just be warned. This is the warning right now. Okay, this is the first thing I want you to notice. Listen for the click. Okay. You can hear that click when I'm mining. It's like, that's because the sound buffer is overriding. What I need to do is create new sound buffers. Also, items delete after 10 seconds now. Let's see, what else do I got for you? So there's a placing sound too. TNT has a new texture. I need to really remove that sound, the sound buffer. It's pretty much an instantaneous cancellation of the sound. At whatever pitch it's at, it instantly goes to 0 at a curve rate of 90 degrees, which is not good. So I need to fix that. Okay, so I actually accidentally showed you this part. You collect items, and it makes the noise. Very fun. Okay, here's the really loud part. You might want to turn down your volume. Oh god. I forget to turn down my headphones. Wow, that's loud. It's probably not as loud because I have the volume turned down a little bit, but it still went almost to the red on my OBS recording, so hopefully I didn't blow your ears out like I just did to mine. And we'll just do that again. I need to create what I created in Lua, a sound buffer manipulation of this, so that it can play a bunch of sounds for the TNT and whatnot, but so that it does not do that. And so we'll just kind of blow up the whole map here. And yes, I forgot to link the sound to the walking animation. I'm gonna have it so when it finishes its swing and it transfers the animation to the other direction, that is going to make like the walk sound like do 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 do. So let's do this. This is going to be very loud. Yeah, that is very loud. We got some that's not. Oh no. We got some stuff that's not blown up over here, so let's just finish it off. I'm sure there's a way I could make this TNT a lot faster, but you know, I'm still learning it. Still creating the base engine. There's always optimizations to be had. I did a bunch of optimizations to get the engine running. Some people were actually saying I was prematurely optimizing the engine, and I'm like, no, no. If TNT takes like a minute to blow up one TNT, then there's a problem. There's a serious problem. So luckily now it is pretty much as optimized as current Minecraft TNT, but I want to make it faster. I'm gonna have to learn how to do that though. See what happens. Okay, in 1, 2, 3. Oh no! Yep, that's pretty much Minecraft TNT right there. Just freeze the whole game. And those items disappear really fast. I feel like I accidentally programmed a bug into it. But anyways. I want to randomize the pitch. OpenAL is the next learning experience. I want to get the OpenAL down and perfect it in the... Well, not perfect it, but better than this, because this is a mess, but it's in there. The hardest part about making an engine, what I've learned, is creating the base and accepting that it's crap. And then working on it. Because you just gotta say, alright, I don't know what I'm doing yet. This is good enough. Let's work on it more tomorrow. And that's what I do. And that's why I take breaks and stream so much. Because it's very difficult to do this. Even I didn't even copy paste the tutorial of the lightweight Java game library. I literally hand coded it piece by piece into my engine. Just to make sure I got everything that was going on. And I think I got enough details from it to create a custom sound buffer in this engine. So, I'm going to do that. And it should be really nice. Pretty much what that lightweight Java game library tutorial that I showed you guys in my other YouTube video, and I showed you guys in my Discord, which the link's in the description. That may be all text, but if you read it and you follow the GitHub chapters, which they're somewhat, it's a little sloppy, I'm not gonna lie, but it's good learning material. Just don't copy paste it, because you won't learn anything. Like, this is what, week 3 of Java? We got sounds already. It's a miracle. Oh my god, I forgot to mention collision detection is now fixed. I overlooked it so much. I forgot to tell you guys. The collision detection system is now very solid. I'll show you guys in a second. I will show you guys in a second, but I want to blow up Sport TNT first. Just gonna do this, and we're gonna connect this. And I'm not gonna move my mouse, because my mouse acceleration moves the it moves my mouse out of the way. That happens in Minecraft too for some reason, but I don't know. It also happens in Minetest if a game lags too hard. Alright, we're gonna look this way. Good lord, man, it's like echoing through my microphone. So you can see, there are some optimizations to be had with the TNT. I'm really proud of the TNT if you can't tell, but there's some optimizations to be had with the TNT, and you can see the premature, mature, immature, infantile, whatever you want to call this, the prototype stages of this lighting system. Also looks very nice. I don't know what it is about this. For some reason, I always thought Minecraft's lighting system looked really nice with the binary states, but it looks nicer with lighting values, and that is actually uncommented in the engine. It's in there. I just need to make it work faster. It's sorry. I literally just tried to say two things at once. It needs to be taken day by day, and that takes time. But give it a month or two, and we'll have a infinitely generating world. I'll just let it go, and you guys can just walk to the world border. Wherever the game crashes, that's where the world border will be. There you go. It's going to be some very complex math, but only in the base level. Now I'll show you guys the code because I'm going kind of like ranty here. Let's see. We have our chunk. This is our chunk static class. So what I'm going to have to do is do a bit shift of all. Always add by files, please. Oh god. Alright, it added them. What I'm going to have to do is something special with this, right? So you have your chunks that you have generate, okay? So what I'm going to have to do is move them over when you walk into a new chunk, and I'm going to have to do this in some special way. I don't know if I'm going to have to use a hash map, or I'm going to have to use a special map. Something besides an array, I'm not sure, but I'm going to have to do something, even if it's not the same as this. This is the fastest I can get the memory access. Well, despite using the buffer utilities, but we're not going to do that yet because that's some that's literally just C performance. Let's see what else. What else was I going to show you? I was going to show you something cool. I totally forgot. I can't remember. Well. Oh yeah, I remember. I had to decompress for a second because I just did so much work. Sorry about that, but my collision. This is what I'm so proud of. I had to study what Minetest's collision was doing, right? Because something wasn't right. And so I didn't use any of Minetest's actual code, but I'm going to give credits up here for the file. And also, since this is GPL 2.1, it's compliant with me iterating through the code. And I'm not going to copy word for word, function to function, enumeration structures, because well, first of all, I don't like how that works in the code, and I feel like it could be a lot faster. But second of all, I want to make it my own way. That's what I like to do. That's why I make it my own game engine, you know. So what the problem was, all right? The big problem was you have to apply inertia and then collision detect and then correct. What I was doing before was shoving the inertia in and then not worrying about it, okay? So I'm going to show you this. You probably aren't going to understand this, but that's okay because this is a little complicated, and I'm doing some things slightly inefficiency in here for the sake of debugging. So when I put in stairs, I'm going to have to refactor this whole collision.java file because it can be faster. But I'm just simply doing a switch statement. Let me show you inertia to direction. This is a very simple statement. This checks within 10, 100, 1000, 10,000. I think that's the 10,000th of float precision 0. Float precision 0. And it will check this float precision because what is happening when you move around, right? Technically, even though the pixels on the screen are not shifting anymore, you still are carrying inertia. And at basically, it's a non-visual level. I can't say microscopic because this is a video game, but at a sub-pixel level, you're still technically moving. It doesn't actually move you even if it stood there, or you stood there after moving for like a year, you would not move because the collision division is doing basically a 0 float imprecision. But what this does is this removes the float imprecision, and if it reaches within these boundary checks, it will return these, or sorry, if it exceeds these boundary checks, it will return these. If it's between 0.0001 and negative 0.0001, it will return 0 because that is the 0 float error. I spent literally 2 hours tuning that to make sure you cannot see it when it essentially jolts it to stop it from moving. It was very complicated, but that's okay. I did a special switch statement, or well, Boolean statement. This is doing an inversion check. What does that mean? Okay, we're gonna bring out paint. This video is gonna be like 30 minutes long. That's okay. I'm sure everybody would like to see what this means. Okay, so let me try to. Oh God, this is not going well. Let's do this. All right, let's get it just barely on the screen and right there. Okay. So this is our inversion check. AABB get left. We're just going to do the get left and the get right in the top of the bottom because this is the third dimension and this is a two-dimensional program. And I deleted Paint 3D, so we can't show that. So AABB get left, right, is greater than box.getRight. Okay. This one, right? That's actually false because this is within that boundary, which is infinitely to the left, okay? And then we inverse that. This is less than that. I'm sorry, that was actually like the opposite. This is very complicated to explain if you couldn't tell. Basically, this statement means, is this out of the boundaries of this? So if I create another one, right? This is a true statement. That's still true. This is always true. It's false now. It's false, it's false, it's false. It's true. How is that very helpful? Okay, you can always tell when the object is outside of the blocks. I think I just said blocks. I meant to say block box. Well, you could just simply take this entire thing, because it's OR statements, and invert it. So now, if all of a sudden one of these is false, then this becomes a true statement. This is within this. Very nice. Very simple. So, hopefully that you could just go into the code and copy that if you want to use this for your own project. I don't care. GPL 2.1, but you could do whatever you want with it. I don't give a crap if you've rebranded as MIT. Let's see. What else do we have in here? Detect block, of course. This is used in the raycasting. This is the same statement as above, but I just simply have this. Oh, by the way, these are static now. I figured the AABB collision handling being objects was probably not good. I explained this in the Discord as if you have a favorite like pencil or something, say you have a favorite Lego block, I don't know, whatever, but you always put it back in the same spot. Okay, you always want to put it back in the same spot. You don't want to just randomly throw it around and you have to go find it. And that's what putting these as objects was essentially doing. It was slowing it down. So literally 400 objects would bring the game to a crawl. Now I can spawn about 4,000. If I do this, where did I put this? I got too many things open. This is not going well. Player. It's right here. This is my multi-line comment. And we need the sound manager. This shouldn't play sounds, but just be warned. This might blow out your ears. Okay, it doesn't. Very cool. Okay, you guys could see that pretty well. Okay, so we have it's got a couple thousand items here. You can see it's like a fountain. It's crazy. So you can see that it's still running. It's starting to slow down now. Starting to slow down a bit. Oh, stop. Oh, the items are deleting. Yeah, we're going to have to get some more items in here. I'm just going to walk backwards because it's going to get very hectic. Okay, this is now managing a lot of items. And it's going to start speeding up right about now. Very cool. So let's just do this. Let's see what this sounds like. Cool, right? That is pretty cool. Well, at least I think it's cool. um, yeah, making these static was extremely handy, because if we go back into the collision object, right? Each one of these are special designed methods. Well, technically they're with a word for it in Java. These are specifically designed to handle one element of the collision axis with a precision of 0.1. They all have float precision of 0.1. So that way, if you somehow manage to get yourself stuck, or you want to start glitching, then you won't get thrown across the map infinitely. I did that for that specific reason, so you don't have to worry about the collision detection destroying your life, basically, when you play the game. Okay. Well, I know what you're saying right now. What is any of this about, right? Let me show you. So we have a switch statement that inertia direction that I was talking about. It does -1, 1, and then the default would be if it was a case 0. If it's 777, which this should be a Boolean, obviously, but I was prototyping it, it's whatever. If that doesn't equal 777, which 777 is well outside of the boundaries of the y-axis of the map because its height's 127 technically from 0 count, then it won't run this, but if it does, it will run these very specific collisions, right? And this is why I do a switch statement inside of this. And that's why these are specific things, because I don't want to make the CPU work harder to do these calculations. I don't want to do this constant check of this up Boolean or up integer every time this has to run this loop. And that's why these are specifically broken down with the switch statements to make them faster. Let's see. Okay, also, this switch statement automatically assigns the collision axis base position of where it's colliding. So, let's see. Let me try to do this. Why can't I delete this? Oh, God. If you move it up, this is the only thing that's getting collided with. This takes your position up here, and it will accumulate it into block positions, right? That's what happens here. If you're falling downwards, it takes the lower part of your Y box, and then it does a specific check around it. And now, in these specific case scenarios, we have this is within after the set AABB, which is the current collision object, and then we have the block box that's getting set up. What that means is that's terrain collision. That is how you're colliding with the terrain, basically, and that's going to be refactored into block boxes. So we do all that. We check down if you're going down, and then we check up if you're moving up. And Y collision detection is now done because we're going to do this one axis at a time, and that's where this comes in. This is actually in the wrong spot, but I'm going to leave it alone. I'll fix it later on. So now we check X, and this is the most difficult thing that it took me way too long to understand this. It took me literally weeks. I've been trying to do this for weeks until I took a look at my old collision code that I wrote for the Minetest engine, which is on my GitHub, where I made the stairs, step down, and all that stupid stuff. But I was like, how is this doing this? Why is this allowed to do this? How can this do this? And I realized what it was doing, and you have to move one axis at a time, which turns it into one-dimensional collision detection, essentially. It's not really one-dimensional collision detection, but you're checking box to box. And what I'm meaning by this, right? Let's say we have this. Right? We're going to draw some really bad blocks right here. Let's say you're here right now, and the next step, you're right here. You're moving downwards at a certain inertia value. So what is happening is this is taking your case -1, checking your position, because the base of your position is right here. This is your actual literal position on the Y, and let's just say this is the x-axis. And what's happening is it is going to integer this, which will automatically floor this. And I know I have floor right here because I don't know why I put it to math.floor. It's an extra step, but whatever. I'll just leave it like that. Now we're going to check. Let's pretend this is two-dimensional, right? We're going to check the x-axis, and now we're going to detect a block right here. Okay, there's a block, and now all of a sudden, this function down here. Where's the positive? No, it's technically negative. But whatever. This is a lot to explain. This detects with this block because we're doing negative to positive, right? All of a sudden, you are moved up here. Your collision box is now no longer going to collide with anything, and you're good. And even if there was a block right here, you magically clipped into something, you will not collide with that block because there is a float precision of 0.1 from the top of this axis boundary right here to the bottom of your axis boundary, which is your base position. So hopefully it makes sense, and that happens for every axis. And so let's pretend that happens in all 3 dimensions, right? That's exactly what's happening. And that's why this is case negative, case 1, and this swaps it over, and it literally flips it over, and then it steps through your collision box height by 0.5 float precision to find that. I think it's pretty nifty, honestly. And the same thing happens with the z-axis. But stepping through axis by axis, you actually gain the ability to do more complex collision shapes. I noticed what the Minetest engine was doing. I'm not sure if they updated it, but whatever's in my Git repo right now, I noticed that let's say we have this, right? We have this, and this is a stair. Oh god, that looks awful. But let's say we're right here. Find the nearest collision box. Okay, it's this one. Find the nearest collision axis. Okay, it's this one. And it kind of does it that way. It's very strange, but what I think I can do is subdivide these. Basically, I'll just collide with this and then collide with this one, or vice versa, and see what happens. Because if you're on the y-axis and you're going to collide right here, you're going to collide with everything no matter what. You're going to hit this. Okay, you're now... Well, you're not going to hit that actually, because that's within float precision of 0.1. So you're not going to even remotely be within this one. But you're going to be within this one. And by the way this looks in the two-dimensional photo, you're going to be within this one on all axes. At least the X and the Y. We're going to assume that magically you're over here and you're still within that. Okay, beautiful. Look at that. Now you're going to get moved up with the step. Okay, hopefully that explains what I'm going to do with the stairs and the slabs, because that's going to be very complex to implement. But basically, I understand how the collision detection works, and hopefully I can help teach you guys about the collision detection system with voxel-based games as I learn how to do it more, because I think this is very interesting. Collision detection correction is it's been something that has been very difficult for me over the years, and I want to make it completely crystal clear for anybody that wants to do any complex collision detection systems that are voxel based, because there's a lot of shortcuts you can take with them. But anyways, this wasn't supposed to be a tutorial. I'm going to upload this video anyways, even though I'm probably going to be like, why did I post that? And hopefully you guys enjoyed this video. So, I'll see you in the next one, and peace out.